Hello, and welcome back to our astronomy course. Today, we will be studying the lecture number 1, part C. Okay, so 1 second, please. I just open my presentation. And at this lecture, let's continue study comets. Okay, I hope it's very nice, interesting talk. How do comets help explain the formation of the planet? This argument must refer to the solar nebula hypothesis. The planetimals that form in the inner solar nebula were warm and could not incorporate much ice. The asteroid may be the last remains of such rocky bodies. In the outer solar nebula, the planetimals contain large amounts of ice. Many were destroyed when they accreted together to make the Jovian planet, but some survived. The icy bodies of the Oort cloud and the Kuiper belt may be the solar system's last surviving icy planetimals. When the icy objects have their orbit perturbed by the gravity of the planet or passing stars, some are redirected into the inner solar system, where you see them as comets. The gases released by comets indicate that they are rich in volatile materials such as water and carbon dioxide. These are the ices you would expect to find in the icy planetimals. Furthermore, comets are rich in dust with rocky-like chemical composition, and the planetimals must have included large amounts of such dust frozen into the ice when they form. And thus, the nuclei of comets seem to be frozen samples of the ancient solar nebula. Nearly all the masses of a comet is in the nucleus, but the light you see comes from the coma and the tail. Build a new argument to discuss observation. What do spectral comets tell you about the process that converts dirty ice into comets? For centuries, suspicious people have associated comets with doom, which seems silly. All right? I hope you agree with me too. Comets are graceful visitors from the icy fringes of the solar system. But comets and asteroids do hit planets now and then, so you might wonder just how dangerous such impacts would be. Astronomers have good reason to believe that comets, very large meteorites, and even asteroids can hit planets. Those links watched in the air in 1994 as fragments from the nucleus of comet Shoemaker-Levy 9 slammed into the Jupiter and produced impacts equaling millions of megatons of TNT, 3-nitrotoluol. Let's look at this slide. Also, astronomers have found chains of craters on solar system objects that seem to have been formed by fragmented comets, as like on this slide. Meteorites hit Earth every day, and occasionally a large one can form a crater. Earth is marked by about 150 known meteorite cracks. No one has ever seen as an asteroid hit a planet. But there are some very big craters in the solar system that show what can happen. A large impact on Earth could have devastating consequences. 65 million years ago, at the end of the Cretaceous period, over 75% of the species on Earth, including the dinosaurs, went extinct. Scientists have found a thin layer of clay all over the bore that was laid down at that time. And it is rich in the element iridium, common in meteorite, but rare in Earth's crust. This suggests that an impact occurred that was large enough to have altered Earth's climate and caused the worldwide extinction. Mathematical models combined with observations create a plausible scenario of a major impact on Earth. Of course, creatures living near the site of the impact would die in the initial shock, but then things would get bad elsewhere. An impact at sea would create tsunamis or so-called tidal waves, many hundreds of meters high that would sweep around the world, devastating regions far inland from core. On land or sea, a major impact would eject huge amounts of pulverized rock high above the atmosphere. As this material fell back, Earth's atmosphere would be turned into a glowing oven of red-hot meteorites streaming through the air. And the heat would trigger massive forest fires around the globe. Food from such fires has been found in the layers of clay laid down at the end of the Cretaceous period. Once the fire source cooled, the remaining dust in the atmosphere would block sunlight and produce deep darkness for a year or more, killing off most plant life. At the same time, if the impact site was at or near limestone deposits, large amounts of carbon dioxide would be released into the atmosphere and produce intense acid rain. Geologists have located a crater at least 180 kilometers in diameter, centered near the village of Chickalbau. More exactly, commented called this place as a Chicxulub in the northern Yucatan region of Mexico. Also, the crater is now completely covered by sediments. Mineral samples show that it contains shocked quartz, typical of impact sites, and that it is exactly the right age. The impact of an object 10 to 14 kilometers in diameter formed the crater about 65 million years ago, just when the dinosaurs and many other species died out. Most Earth scientists now conclude that this is the scar of the impact that ended the Cretaceous period. There are a number of major extinctions in the fossil record, and at least some of these were probably caused by large impacts. Large asteroid impacts on Earth happen many millions of years apart, but they continue to happen. In mid-March 1998, newspaper headlines announced mile-wide asteroid to hit Earth in October 2028. But the news media did not emphasize the uncertainty in the asteroid's orbit. Within days, astronomers found more images of the asteroid on all photographic plates, recalculated the orbit adding the new data, and concluded that the asteroid known as the 1997 XF11 would miss Earth by 600,000 miles. There will be no impact but that asteroid in 2028. But there are plenty more asteroids in Earth's crossing orbits that haven't been discovered. It is just a matter of time. And maybe you can help us in this case. Human civilization is spread out over Earth's surface and exposed to anything that falls out of the sky. Meteorites, asteroids, and comets bombard Earth, producing impacts that vary from dust settling gently on the rooftops to disasters capable of destroying all life. In this case, the scientific evidence is conclusive and highly unwelcome. Statistically, we are quite safe. The chance that a major impact will occur during your lifetime is so small it is hard to estimate. But the consequences of such an impact are so severe that humanity should be prepared. One way to prepare is to find those objects that could hit us, map their orbit, and identify any of their dangers. What we do next isn't clear. Blowing up a dangerous asteroid in space might make a good movie, but converting one big projectile into 1,000 small ones might not be very smart. Changing an asteroid's orbit could be difficult without a few decades advance warning. Unlikely or not, large impacts demand consideration and preparation. Throughout the universe, there may be two kinds of inhabited worlds. On one type of world, intelligent creatures have developed ways to prevent asteroid and comet impacts from altering their climate and destroying their civilization. But on other worlds, including Earth, intelligent races have not yet found ways to protect themselves. Some of those civilizations survive and some don't. And let's begin to our summary. The term meteoroid refers to small solid particles orbiting in the solar system. The term meteor refers to a visible streak of a light from a meteoroid heated and glowing as it enters Earth's atmosphere. The term meteorite refers to space material that has reached Earth's surface. Iron meteorites are almost iron and nickel. When sliced open, polished, and etched, they show with constant powder. This reveals that the metal cooled from a molten state very slowly. Stony meteorites included chondrites, which contain small glassy particles called chondrules, believed to be very ancient droplets of molten material formed in the solar nebula. Stony meteorites that are rich in volatiles and carbon are called carbonaceous chondrites. They are among the least modified meteorites. Many meteorites appear to have formed as part of larger bodies that melted, differentiated, and cooled very slowly. Later, these bodies were broken up and fragments from the core became iron meteorites, while fragments from the outer layers became stony meteorites. The evidence, including the orbits of meteorites, seen to fall, suggests that meteorites are fragments of asteroids. The vast majority of meteors, or visible streaks of light from particles heated by passage through the atmosphere, including meteors in meteor showers, appear to be low-density, fragile bits of debris from comets. Most asteroids lie in a belt between Mars and Jupiter. Also, the Trojan asteroid-shaped Jupiter orbit and others have orbits that cross into the inner solar system. If they pass near Earth, they are called near-Earth objects, NEO. C-type asteroids are more common in the outer asteroid belt, where the solar nebula was cooler. They are darker and may be carbonaceous. S-type asteroids are the most common and may be the source of the most common kind of meteorite, the chondrite. S-type asteroids are more frequently found in the inner belt. Carbonaceous chondrites appear to have formed farther from the Sun. M-type asteroids appear to have nickel-iron compositions and may be the cause of differentiated asteroids shattered by the collision. The asteroid formed as rocky planetesimal between Mars and Jupiter, but Jupiter prevented them from forming a planet. Collisions have fragmented all but the largest of the asteroids. Most of the material inferred to have been originally in the asteroid belt has been gravitationally perturbed and swept up by the planets or tossed out the solar system. A comet is produced by a lump of ices and rock about 1 to 10 kilometers in diameter, referred to as the comet nucleus. In long elliptical orbit, the icy nucleus stays frozen until it nears the Sun. Then, some of the ices vaporize and release dust and gas that is blown away to form a tail. A type 1 or gas comet tail is ionized gas carried away by the solar wind. A type 2 or dust tail is solid debris released from the nucleus and blown outward by the pressure of sunlight. A comet's tail always points away from the Sun, no matter in what direction the comet is moving. The comet or head of a comet can be up to 1,000,000 kilometers in the diameter. Comets are believed to have formed as icy planetesimals in the outer solar system, and some were ejected to form the Oort cloud. Comets perturbed inward from the Oort cloud become long-period comets. Other icy bodies form in the outer solar system and now make up the Kuiper belt beyond Neptune. Objects from the Kuiper belt that are perturbed into the inner solar system can become short-period comets. A major impact on Earth can trigger extinctions because of global forest fires caused by heated material falling back into the atmosphere, tsunamis inundating coastal regions around the globe, acid rain resulting from large amounts of carbon dioxide released into the atmosphere, and climate change caused by the atmosphere filling with dust, plunging the entire Earth into the darkness for years. An impact at Chicxulub in Mexico's Yucatan region 65 million years ago appears to have triggered the extinction of 75% of the species then on Earth, including the dinosaurs. Do you have any questions or propositions? Next topic will be the Sun. And for this moment, I hope you enjoyed this lecture, and I'm looking forward to seeing you next time. Bye.